Good morning. Today's lesson equivalent decimals. Firstly, the meaning of equivalent decimals. Equivalent decimals are decimals that name the same number. You must know, putting zeros to the right of the last digit in the decimal doesn't change the value. For example, 0.65 and 0.650. We put 0 here after the last digit. They are equivalent because this 0 doesn't change the value. 0.8 and 0.800. Here we put 2 zeros after the last digit in the decimal. Also, these 2 zeros doesn't change the value, then 0.8 and 0.800 are equivalent. 0.08 and 0.80. Here we have 2 digits after the decimal point, and also here we have 2 digits after the decimal point, but here this 08 and the other is 80. For that they are not equivalent. 0.98 and 0.098. If we put 0 after the last digit here, it will be 0.980. It's not the same 0.098, then these two decimals are not equivalent. The first exercise. Are the two decimals equivalent? Write equivalent or not equivalent. 0.7 and 0.70, 0.04 and 0.4. In the first one, 0.7 and 0.70, we have one digit after the decimal point here and the 2 digits after the decimal point here. We put 0 after 7 to make it 2 digits like the other decimal. If we compare between them, they are the same. For that, these two decimals are equivalent. But 0.04 and 0.40, here we have 2 digits after the decimal point and the other one have only 1 digit. We put 0 after 4 to make it 2 digits also like 0.04. If we compare between them, they are not the same. Here 0.04 and the other 0.40, then these two decimals are not equivalent. C, 0.9 and 0.09, and D, 0.28 and 0.82. Here we have only 1 digit and the other has 2 digits. We put 0 after 9 here to make it 2 digits also like 0.09, and if we compare between them, they are not the same. For that, they are not equivalent. D, 0.28 and 0.82, the two numbers are not the same, 28 and the other 82. For that, they are not equivalent. Another example, 0.1 and 0.10, 0.05 and 0.5. In E, we put 0 after 1. It will be 0.10, like 0.10 the other. They are equivalent. If we compare between them, they are the same. For that, they are equivalent. And F, 0.05, and we put 0 after 5 here to make it 2 digits also, like the other one. If we compare between them, they are not the same. For that, they are not equivalent. 0.8 and 0.800, 0.75 and 0.70. In G, we put 2 zeros after 8 to make it 3 digits like the other one. And when we compare between them, they are the same. For that, they are equivalent. And H, 0.75, 0.70, here 75 and here 70, they are not the same. For that, they are not equivalent. Now, another exercise, write an equivalent decimal for each. 0.8, 0.98, 0.90. To write an equivalent decimal, write the same number and put 0 after it. This will be 0.80, 0.98, write it the same and put 0 after it. It will be 0.980. 0.90, write it the same and put 0 after it, because we said zeros to the right of the last digit in the decimal doesn't change the value. Another example, 0.07, 0.4, 0.500. Write the same number and put 0 after it. This will be 0.07 and put 0. It will be 0.070. 0.4 the same and put 0. It will be 0.40. 0.500, write it the same and put 0. It will be 0.5000. Another example, 0.17, 0.49, 0.6. Write the same number and put 0 after it. It will be 0.170. 0.49 the same and put 0. It will be 0.490. 0.6 the same and put 0 after it. It will be 0.60. Now, another exercise. Write the following decimals as a fraction. 0.9, 0.45, 0.373. To write the decimal as a fraction, write the number after the decimal point as a numerator, like this. 9. And we have here one digit after the decimal point. If you have one digit, it will be over 10. If you have two digits, it will be over 100. If you have three digits after the decimal point, it will be over 1000. For example, here 0.45, we have write 45 as a numerator, and we have two digits after the decimal point, it will be over 100. 0.373, write 373 as a numerator, and because we have three digits after the decimal point, it will be 1000. Again, if you have only one digit after the decimal point, it will be over 10. If you have two digits, it will be over 100. If you have three digits, it will be over 1000. Another example, 0.008. 8 is the numerator, and because we have three digits after the decimal point, it will be over 1000. 0.09. 9 is the numerator, and because we have two digits after the decimal point, it will be over 100. 0.014. 14 is the numerator, and because we have three digits after the decimal point, it will be over 1000. Now the opposite. Write the following fractions as a decimal. We have fraction, and I want to write it as a decimal. 9 over 10. 9 over 10 means 9/10. It will be 0.9, because 9 here in tenths place, as we said before in the standard form. 45 over 100. It means 45 hundredths. If we write it in standard form, it will be 0.45, 45 hundredths. 373 over 1000. It means 373 thousandths. 0.373. 373 thousandths, because 3 here in thousandths place. 8 over 1000. 0.008, because 8 here in thousandths place. 9 over 100. 9 hundredths. 0.09. 9 here in hundredths place. 14 over 1000. It means 14 thousandths. 14 thousandths means 0.014. It's like the standard form. Now we have three special fractions: half, 1 over 4 or quarter, 3/4. It's like the money. Half pound equals 50. Then half equals 0.50. Quarter pound equals 25. Then quarter equals 0.25, 25. 3/4 equals 0.75. This is the end of our lesson. Thanks.